before I, like I said, introduce the speaker, I wanted to take a minute and give you a brief introduction of what SLOconf is, and especially to all our new friends here today. So we are, as far as I know, the only event and conference, because this is based on a conference, dedicated to the practice and application of SLOs, which is service level objectives and reliability. And our first meetup was, funny enough, held in person in Seattle, and it was meant to be a in-person meetup. It was at the beginning of 2020, so right before COVID. It later became a virtual meetup due to the COVID restrictions, but it ended up actually being a good thing for us that it became a virtual meetup, because now we have people from all corners of the world joining. We also brought a conference to the community, which we called SLOconf. And SLOconf ended up being just this amazing conference. It was all virtual. We had each time around 50, 60 speakers, and all those talks are online. You can find them on our YouTube channel. I can link them below if anyone's interested, but all of them are, there's no sales pitch. All of them are just basically educating the community about the practice of SLOs, talking about use cases with SLOs, experiences, how to build a culture on SLOs. It's just, it was a very great conference. Without any further ado, I will present to you Alexandra McCoy. Alexandra will be talking about SLOs gone wild, advanced strategies for surviving service level chaos.
Alrighty, so today's call is titled SLOs Gone Wild, and I'm gonna go through a few different strategies that your organization or your team can utilize to preserve your SLOs. So I do have a bit to say about each topic, so I'm going to go ahead and dive in. For anyone that does not know, because I'm working under the assumption that everyone is somewhat familiar with SLIs, SLOs, and SLAs, but SLO preservation is the concept of implementing different processes and practices into your SLO process in order to reduce the amount of error budget or burn rate that your organization experiences. And SLOs are backed by what we call SLIs, which are service level indicators that are metrics that are used to calculate the availability, performance, uptime, whatever it is that you're measuring against your application, service, or platform. When it comes to SLO preservation, the benefits of some of these advanced strategies are reducing burnout from your on-call engineers, increasing reliability validation for the performance of your services, improving resource allocation, as well as reducing risk mitigation and improving cost efficiency for your organization. So our first strategy for today is called closed loop incident management. I do have a background in product support, as well as incident management for platforms, as well as help desk support. So incident management, I would like to say, is my cup of tea. So a lot of the strategies for today will cater to that side of the reliability practice. So closed loop incident management is also referred to as CLIP, and it automatically takes actions on your alert from detection to remediation phases, while integrating that remediation process within your ticketing system and validating the success of the steps taken. This all occurs without human intervention and typically manages the entire incident lifecycle. The concept of a perfect world where incidents are swiftly detected, triaged, and resolved without human intervention leads us towards our next strategy, automated incident response orchestration. You might hear me call it ARROW for short. I don't know if they do that in the industry, but it's a lot to say. This strategy involves implementing automated workflows and scripts that spring into action the moment an incident occurs. So let's think about some of the popular e-commerce platforms that we might interact with on a daily basis. And let's say one of those platforms are experiencing a sudden surge in traffic due to having a flash sale. As the number of users spikes, the system servers will start to show signs of strain, and the CPU usage will hit alarming levels or whatever thresholds are configured within that organization. Before the spike in traffic becomes a full-blown outage, automated incident response orchestration will kick in, The orchestration tool detects the anomaly in CPU usage. It'll triage that issue to determine the severity, and then it'll initiate predefined responses. In this scenario, the tool automatically scales up the server resources to handle that increased load. It'll redistribute incoming traffic to less burdened servers and alert the engineering team regarding the incident. All of this is going to happen within a matter of seconds, and it'll ensure that the e-commerce platform remains operational and responsive throughout the sale. By automating incident response this way, the organization can significantly reduce response time and minimize the impact of incidents on service availability and reliability. So it's similar to having a team of tireless responders working around the clock, ensuring that any hiccups in the system are swiftly addressed before they turn into major outages. And if we have any on-call engineers on the call, then we know what it's like to work those 24/7 rotations, and we want to avoid that as much as possible. So Arrow is a strategy that will definitely help with that engineering burnout. But it's also not just about speed. It enhances consistency and reliability utilizing those pre-configured workflows and scripts. There's no human error, and there's also variation in the response procedures that are used. So every incident will get handled with the same level of precision, the same level of efficiency, regardless of the time of day or the experience of the responder handling the incident, which we all know whenever we're onboard into a new organization and joining that on-call rotation, the more human interaction that we have, the more chances for error. So in this instance, it's all about taking control of the chaos and ensuring that we reduce downtime, and downtime becomes a thing of the past. As we increase our automation capabilities, we can then begin to think of strategies such as AI-driven anomaly detection. This strategy utilizes the capabilities of machine learning algorithms and AI-powered systems to identify anomalies that could signal potential incidents or breaches of your SLOs. So in this instance, let's think about major financial institutions, which handles millions of transactions on a daily basis through some kind of online banking platform or mobile application. Sometimes these platforms can experience high volumes of data flowing through the system, and detecting abnormal patterns that could indicate some kind of fraudulent activity or that platform experiencing a system failure. To automatically detect these, it can be a little bit difficult. With AI-driven anomaly detection implemented, a financial institution can sleep somewhat peacefully because we know reliability is never 100%. The system will continuously monitor various metrics that are configured, such as transaction volumes, login attempts, user behaviors, and use those machine learning algorithms to establish some sort of baseline pattern for whatever that platform's normal should be. So let's say this platform experiences a sudden surge in login attempts from unusual locations, or there's a spike in transaction volumes during off-peak hours. Deviations from the established norms may indicate a potential security breach or a system overload. Before these anomalies escalate into full-blown incidents or violate the configured SLOs, the AI-powered system can take control, alert the security team, or initiate predefined response protocols. So in this instance, that institution will be able to proactively intervene by implementing security measures to prevent that unauthorized access and scale up resources to handle the increased workload. By addressing potential issues at their inception, they are automatically minimizing the risk of service disruptions while also maintaining compliance with their SLOs and safeguarding the integrity of their systems and data. Speaking of chaos, let's imagine that we have a crystal ball and it allows us to predict and prevent system failures before they even happen. This is how we should consider the strategy of chaos engineering. This approach is going to involve proactively testing your system's resilience and failure scenarios under controlled conditions to identify weaknesses and vulnerabilities. If anyone has worked for any of the, a small or a large cloud service provider or for a SaaS organization, then you'll be familiar with how they host critical applications and services for millions of users, and sometimes those users are globally distributed. Organizations that are managing platforms or applications on such a scale can experience massive high availability and reliability needs for their application platform. So with this massive infrastructure, it's important to ensure high availability and reliability to maintain the customer trust and satisfaction. With chaos engineering, cloud service providers can take a proactive stance towards system resilience. Instead of waiting for incidents to happen, they can intentionally introduce failures into the infrastructure in a controlled environment. They might simulate network outages, server failures, or sudden spikes in user traffic during peak hours as well. By intentionally causing failures, they can observe how their systems respond and identify any weak points or bottlenecks in the system. They can assess the impact of these failures on their SLOs and then refine the incident process procedures accordingly. So let's think about a scenario where an organization is implementing chaos engineering on their platform or application, and we deliberately take a server down or take a server offline. In that instant, you want to monitor how the system is rerouting traffic when the server is taken offline. An organization might even decide to scale up those resources in order to maintain service reliability. In this instance, you'll be able to gather valuable data on response times, error rates, and customer impact, which will enable you to fine-tune your incident response playbooks and optimize your infrastructure for resilience. When we embrace chaos engineering, we're able to uncover hidden vulnerabilities, strengthen our system's defenses, and then build a culture of resistance and preparedness. So instead of fearing failure, we should embrace it as a catalyst for improvement. And if we think about the setup of a cloud platform that's running globally distributed applications, managed by different teams, we can think about the different components that it takes to create a platform or a cloud application catalog. If we think about the components involved in the last scenario, it highlights the needs to develop comprehensive service dependency maps to understand the interdependencies between different components and services within that underlying infrastructure. This enables organizations to identify critical dependencies that could impact SLOs during incidents and implement proactive measures to mitigate risks. So I don't know if anyone has been through a corn maze. Imagine trying to make it through a corn maze with a blindfold on. That's exactly what it's like trying to manage complex infrastructure without service mapping. Dependency mapping can also be compared to a high-tech GPS system for your infrastructure, which is going to help you to develop these different maps for interdependencies to find your way through the system and identify different components that might be involved with an active incident. If we think about a SaaS company that provides a suite of cloud-based applications to globally distributed businesses with service dependency mapping in place, you can gain valuable insights into the infrastructure's inner workings and create these comprehensive maps that visualize the relationships between various services, databases, APIs, and third-party integrations. For example, let's think an application experiences a sudden spike in user registrations that not only impacts their authentication service, but also puts strain on the backend database and payment processing systems. That organization would not have any insight into this from looking at a single service perspective, but a service dependency map will help them to identify the other services surrounding that incident that are also impacted by this spike in user registrations. In this instance, they might even want to implement redundant systems or failover mechanisms to mitigate the risk of service disruptions. They could also prioritize certain services for maintenance or optimize based on their importance to the overall system. So the service dependency map is not just for identifying what services are impacted during an incident, but it can also help you to plan how you want to mitigate that risk, how you want to go about remediating an active incident, and what component down and which ones have been taken offline, or have impacted other workflows within your application process. So if we consider this same scenario, let's say a third-party API experiences downtime. If a service dependency map has been implemented, that company is also able to quickly identify the effective services, reroute traffic to alternative endpoints, and then minimize the impact to their customers and maintain service availability within those acceptable limits or the SLO thresholds that they have configured. As we remediate or mitigate incidents, we want to also consider opportunities to leverage dynamic SLO adjustment capabilities. So let's pretend we're driving a car, and I know everyone is familiar with Teslas, but let's pretend we're driving a car with an automated steering wheel that automatically adjusts on road conditions. That's the essence of dynamic SLO adjustment. This strategy involves implementing mechanisms that adapt SLO targets in real time based on the incident's severity, the user demand, or system load, and if you're working with a specific platform, any other metrics or configurations that have been enabled in that environment. So let's again consider a tech company in this scenario. And this company provides an incident management platform that's used by businesses to streamline their response to service disruptions. With a diverse range of clients across industry, ensuring that response efforts are prioritized effectively and resources are allocated in alignment with business priorities is extremely crucial to maintaining customer satisfaction and loyalty. When it comes to SLOs, SLOs are typically backing our SLAs, and SLAs are set with our external customers that are paying us for a specific service. So customer satisfaction and loyalty is always important and always the end goal in whatever processes we're using to run our applications. With dynamic SLO adjustment in action, this incident management platform offers its clients the flexibility to tailor their SLO targets dynamically based on changing circumstances. So during periods of high user demand or increased system loads, the client may opt to relax certain SLO thresholds or prioritize service availability over response times. Conversely, during critical incidents or service disruptions, clients may also choose to tighten their SLO targets to ensure that quick resolution and minimize any impact on end users. So let's take a different route and consider a scenario where a major e-commerce client experiences a sudden surge in traffic. Again, this organization is having a flash sale. In response, the incident management platform can dynamically adjust the client's SLO targets, prioritizing service availability over response times to accommodate the increased demand. This proactive adjustment ensures that the client's website remains operational and responsive throughout the event, minimizing the risk of revenue loss and customer dissatisfaction. SLO adjustment capabilities, it empowers its clients to adapt to changing circumstances in real time. It aligns response efforts with business priorities and customer expectation. Whether it's scaling resources to handle peak loads or prioritizing critical incidents for immediate resolution, dynamic SLO adjustment ensures that the resources are allocated where they're needed most, maximizing the efficiency and effectiveness of incident response efforts. And last but not least, in current times, we know resource allocation is a high priority as it contributes to saving an organization costs. When considering SLO adjustments, it's also important to quantify the cost of said adjustments. So let's pretend we're running a high-stakes poker game where every missed SLO is a costly bet. That can be compared to quantifying the cost of SLO violations. This strategy involves internally developing methodologies for quantifying the financial and reputational costs associated with failing to meet SLOs. When SLOs are violated, people tend to think about reimbursing a customer for whatever availability was lost. But if it's something that is continuous, there also needs to be calculations for reputational damage. So an organization can also have impact towards their reputation in the industry if SLO violations are a recurring thing. So let's again reflect on a tech company. And this same tech company provides cloud-based storage solutions to businesses. And let's say the tech company experiences a major service outage that lasts for a period of 24 hours. And this outage is due to a hardware failure in one of their data centers. During the outage, thousands of businesses are unable to access their data, which results in a significant financial and reputational experience. To quantify the cost of this SLO violation, we can also outline the following metrics. We can think of loss of revenue, customer churn, and also reputational damage. Let's say that the tech company charges businesses an average monthly subscription fee of $1,000 for their storage service. With thousands of affected businesses unable to access their data for a 24-hour period, the total loss of revenue can be calculated as the number of affected businesses multiplied by the average monthly subscription fee, multiplied by 1 over 30, which is due to a 30-day period in a month. But when it comes to SLOs, there are some organizations that calculate on a 28-day period and multiplying that by 24 hours. This is an example of calculating the financial risk that is lost due to a SLO violation. Additionally, let's assume that 10% of businesses were affected and then they decide to cancel their subscriptions due to the prolonged outage. This can result in a loss of future revenue from these customers, and an organization would need to be able to quantify that as well. However, quantifying reputational damage can be a bit more difficult, but let's assume that negative publicity from the outage leads to a 5% decrease in new customer acquisitions over the following quarter. Then an organization will also need to be able to calculate that reputational damage in order to understand what they need to change and what they need to do to mitigate those decreases going forward. By computing in actual numbers and performing calculations, a company can obtain a concrete understanding of the financial impact of SLO violations. With these insights, they can prioritize incident response efforts and allocate resources more effectively, such as investing in redundant infrastructure to minimize the risk of future outages, or allocating resources to their incident response teams to ensure faster resolution times. Quantifying the cost of SLO violation transforms service disruptions from abstract concepts into tangible metrics that drive these strategic decision-making. By understanding the true cost of SLO violations, companies can make more informed decisions that safeguard the financial health and preserve their reputation in a competitive market. It's always important to remember that SLO preservation is the name of the game.